To solve b, we're going to first start by finding the p's over q's. And again, this one's really nice because q is 1. So we're really only looking for the factors of p, which is 85. So hopefully you got 1, 5, 17, and 85 for your factors. Now, I can tell you already, because all these are positive numbers, there's no way for me to plug in a positive number and get a 0. I have to be able to subtract somewhere. So I've eliminated 4 of the 8 possibilities. I can start with -1, but here I'm just going to get a -58, and that's not going to cancel out this positive 85, so -1 is out. And then if we plug in -5, then we get -125, and then 25 times 13 is 325. And then 57 times -5 is, anybody? 57 times -5 is that -285, and then plus 85. So you add all this together, and what ends up happening? You get a 0. So we have found one of the zeros. Now you're more than welcome to check to see if -17 and -85 work. I am not going to, because this is a cubic polynomial. So by doing synthetic division once, what that's going to do is it's going to break it down to a quadratic polynomial once you divide. And once I have a quadratic polynomial, I can either factor, solve by extracting the roots, complete the square, or quadratic formula. So we have all these different things that we could try to use. So let's go ahead and break down the polynomial. We have -5. We have 1, 13, 57, 85. So 1, -5, 8, -40, positive 17, -85, 0, which is what we expected, a remainder of 0. So now my quadratic is x squared plus 8x plus 17. Now, do any two numbers multiply to 17 and add to 8? No. So at this point, and because I have an x term, I know I can't take the square root of both sides. So I have two options here. I am going to show you both because quadratic formula is the one that I generally just go to automatically. But for some of you, especially when the coefficient is 1, for some of you, completing the square is actually going to be easier, and you're going to find that you have less mistakes. So I want to kind of review that strategy here. So, I'm going to go over both methods. I know you guys did this already, so you guys can kind of follow along with whichever one you did. Most of you probably did not complete the square. So this will be a little bit more review, but once we go back to the quadratic, you might see the simplicity of it. So for completing the square, remember we get the two x terms by itself, and we move the constant to the other side. Our goal is to get a binomial squared equal to some number so that we can just take the square root of both sides and solve by extracting the roots. So to complete the square, I take half the middle term. What is half of positive 8? Positive 4. And when I square that, I get 16. So that is what this is. X squared plus 8x plus 16 is the quantity x plus 4 squared. But I just added 16 to this side, which means? Add 16 to the other. And what is -7 plus 16? -1. So now when I take the square root, I get x plus 4. Now, when you take the square root of both sides, what can you not forget to do? Plus or minus. What is root -1? Final step in solving for x. Subtract 4 from both sides. All right, so you can kind of see if you are comfortable with completing the square, it actually is pretty simple to do for this type of a problem. Okay, so that is one way to do it. Just because I'm used to it, I do find myself leaning towards the quadratic formula. All right, so in this case, I get x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's -8 plus or minus the square root of 64 minus 68 over 2, which is -8 plus or minus root -4 over 2. And that becomes -8 plus or minus 2i over 2. But remember, in order to like cancel this 2 out, it's easier to factor a 2 on top. You get negative 4 plus or minus I, because negative 8 divided by 2 is negative 4. 2i divided by 2 is I. And then we can cancel out, so x is negative 4 plus or minus I. Okay? So two ways. You have your quadratic formula, or you have your completing the square. They're going to get you the same answers, but as you can see, completing the square isn't such a bad idea if you're comfortable having and squaring, right? So you guys have options now. When that comes up, and again, if I had a leading coefficient here, I may not be quite as inclined to complete the square, but if the leading coefficient's 1, it's pretty easy. All right, so then we need to finish the problem. We're supposed to write this in factored form. Now remember, to write in factored form, it's going to be x minus one of our roots and our second root and our third root. Okay, and I know I have 3 roots because my degree was 3, and so I know I have 3 roots. Now my first root we found already was negative 5. So this is x minus negative 5. That's root 1. My second root is going to be x minus negative 4 plus I, and then my third root is x minus negative 4 minus I. So now we just need to distribute our negatives. This becomes x plus 5, which we usually do this one in our head. Generally, we don't write x minus negative 5. You guys know, like, oh, if the root's negative 5, the factor is x plus 5. But this, I wanted to show this just to emphasize this. If you have a binomial root, you want to distribute. So this becomes x plus 4 minus I, and then x plus 4 plus I, and this is completely factored.